Okay, first of all, thank you for all of you, to all of you for coming out to my lecture recital. This will be on my dissertation topic, linear chord scale analysis and improvisation in post-bop jazz harmony, which I know sounds like a huge mouthful, but I promise it's not as complicated as the title sounds, and I will attempt to break it down for you as best I can. With that in mind, here's a little outline of our agenda. I will start with a little bit of background on jazz harmony and how chord scale theory has been traditionally taught. I'm going to talk a little bit about transformational theory, which is the method of analysis that's inspiring how I will work with chord scales and post-bop harmony. And then we will look at some analysis of post-bop harmony and close with some examples of how this can be applied in improvisation. So that brings us to our first topic, the history of jazz harmony and chord scale pedagogy, which begins with Mr. George Russell, who is credited as being the founder of chord scale theory. It's right there on the very first page of his publication, the Lydian chromatic concept of tonal harmony, which you can see in original printing up there. That's George Russell on the left. And George Russell himself got many of these ideas from hanging around the classic bebop cats in the 1940s. And he talks about listening to the way musicians like Miles Davis talked about harmony being the source of his development for chord scale theory. Now, chord scale theory, once it was published, would go on to influence actually a lot of jazz musicians in the 1950s, particularly the modal jazz movement. Once chords are now scales, you can take an entire section of a piece and, of course, just have a single mode instead of a chord progression. And so, of course, you can see how Miles Davis was a huge proponent of that early on. Of course, in the early 1960s, we had the free jazz revolution, which was really disruptive to the jazz community, very divisive as well. And, certain musicians were all in, and other musicians were a little resistant to the kind of openness and free-form, lack of rules that came with the free jazz revolution. And so what you had was a group of musicians that was starting to try to find ways to sort of bridge the gap between traditional straight-ahead jazz playing and free jazz. Probably the most notable example of this would be, once again, Miles Davis with the Second Great Quintet. The musicians in this group, guys like Wayne Shorter, Herbie Hancock, and Joe Williams, were experimenting with different ways to have structure and freedom in the same piece. A few of the ways they did that was to use pieces with kind of varying lengths of form. Instead of just a standard 4 or 8 bar phrase, you had pieces with 7 bar phrases, 14 bar phrases, stuff like that. And another thing they did was they tried to write harmonies that avoided identifying key centers. So there's still the kind of chords you and I might see in a chart, like a C major 7, but the way they're getting between chords really kind of avoids tonicizing a key center. So with that in mind, we'll discuss a little bit of these harmonic details on this slide. Now, a lot of these definitions have come from the theorist Keith Waters. He has a really fascinating book on post-bop jazz harmony and composition, and these are not all of the stylistic identifiers he lists, just the ones that pertain to harmony. So I'll go through each one and play little short examples, starting first with axis progressions. And what we have here is an example from the end of Woody Shaw's composition Moon Train. Axis progressions basically describe any progression that is moving between key centers that are a minor third or a major third apart. So you can see here we have the chord progression moving up in minor thirds. And I'll just play a short clip. Right here. Next, we have constant structure progressions, which are very similar in that they're kind of following chords of the same quality at different transpositions. Usually stepwise motion, but that's not a hard and fast rule. And in this particular example, I have an excerpt from Joe Henderson's composition, Inner Urge. As you can see, we have the same Lydian chord, major Lydian chord, kind of transposed up and down in steps. And here's what that sounds like. Next, we have pedal point progressions, and pedal points are a group of harmonies that share a common root or are superimposed over a shared root. And this particular example comes from Herbie Hancock's composition, Dolphin Dance. It's a composition that actually has a ton of pedal point harmony. This is just one of 3 different phrases that use it. And as you can see, we've got several chords sharing E flat as a root. Next, alternative cadences are pretty simple in concept. It's any dominant chord that doesn't resolve in a harmonically functional way. So we think of typical dominant chord resolutions as being down a fifth or down a half step in the case of tritone substitutions. Alternative cadences is kind of a catch-all for a deceptive resolution in this style of music. So once again, I have a excerpt from Joe Henderson. This is from his tune Punjab. As you can see, we've got a dominant chord that resolves up a half step to C flat major 7. And then lastly is character chords, which is kind of a catch-all for chords that are derived from symmetrical scales, so diminished, hexatonic, or whole tone scales. And in this clip, we have a little bit of Wayne Shorter's composition Wildflower. And you can see in measure 4, we have B flat major 7, sharp 5. Yeah, the B flat major 7 sharp 5, which is a chord that comes from the hexatonic scale. The melody does outline it a little bit, which I think is super cool. But if you listen closely in this example to Herbie's piano voicings, it really stands out. All right, so with the definition of post-bop harmony sort of covered, the next thing I want to dive into for our background is a little bit of the history of how chord scale theory has been taught. So what you see up on the screen here are 4 examples from different methodologies going all the way back to the beginnings of chord scale theory in the 1960s. At the top we have the simplest, which is from David Baker's book, Techniques of Improvisation. And as you can see, it's really straightforward. It's just the scale, the C major scale, going through all the modes of C major. The whole book kind of goes through exercises like this, where he gives you scale patterns and then asks you to take it through every mode of the key. Below that, we have Jerry Coker's Improvising Jazz, a publication from 1964. And this is a method that, if you're like me, will seem like the most familiar, right? We have the basic building blocks of the chord, then its related scale with the chord tones kind of made to be open and the passing tones filled in. This is also how a lot of Jamie Aebersold's publications list chord scales. Very familiar, I think, to anyone who's been through jazz education. And then we do a big leap down to 1995. This is an excerpt from Mark Levine's jazz theory book. And this is an exercise he calls the continuous scale exercise. Now, you'll notice it's not a full chord scale, and it's also not just going up or down in any particular harmony. And that's because the whole point of the exercise is to continue an ascending or descending trajectory across several chord changes. And his point with doing this is that it kind of gets you away from thinking about modes as having a beginning and an end. And then on the bottom, we have an example from guitarist Bruce Arnold. He has a publication from 2014 called Tools for Modern Improvisation. And this is what he calls the 12-tone approach to improvisation. Now, it's not actually atonal like 12-tone music would be, but it's named because it kind of uses the intervallic approach that a lot of 12-tone music uses. So one of the things he advocates for is the use of trichords, which are simple, small, three-pitch groups. And he advises improvisers to analyze whatever piece they're learning. In this case, it's Stella by Starlight, and to base their improvisation around the trichords that occur in the piece. So he talks about Stella by Starlight having a lot of 0-1-2 trichords, which would be 0 to 1 is a half step, and 1 to 2 is a whole step, so half step plus whole step. And so he's written this etude as an example of how you could play over Stella by Starlight with 0-1-2 harmony and melody. And I've whipped up a little computer rendition of this because I know it's super complicated and it may be hard to like conceptualize how it hears, how it sounds. Oops, start back at the beginning. And of course, it sounds a little robotic because it's just a computer playback, but you can get an idea for how it's really shaping the language that he uses a little bit, and one might say masking the chord scale itself in his playing. So that brings me to a couple of really important observations that can be drawn from all these examples. And the first one is that if we look over the history of chord scale theory, teaching it has kind of moved from being very literal, here's the scale, here's the beginning, here's the end, to more and more abstract, which I'd argue is a good thing. To improvise with these scales, we really do need to be thinking about the pitches themselves as abstractions, not as beginning and ending parts of a scale. The second thing that I can draw from looking at these examples is namely that there's not much being talked about in terms of how harmonies flow through each other. Yes, Mark Levine's book talks about playing across chord progressions in the same direction, but really what the ear will gravitate toward when we hear chord progressions is the half-step connections between harmonies. And his book does nothing to encourage you to really highlight that in your practice or your playing. And that brings us to transformational theory. Transformational theory, once again, really complex sounding thing, but I think once it's broken down a little bit, the elements of it, it's actually a pretty intuitive thing to understand. And the history of transformational theory actually starts with theorist Hugo Riemann, who was a classical theorist back in the 19th century. And he noticed there were a lot of problems analyzing late Romantic music with traditional Roman numeral analysis. It was just too chromatic for that to really describe what was going on. So he developed a system of analyzing that sort of music that relies on looking at how smoothly chords voice lead to each other in that style. So instead of saying a chord is a 5 of this key or a 5 of 5 of this key, he's looking at, well, this chord has two notes that are held over between the next chord and etc. I'll have a demonstration in a minute that really highlights how this works. But suffice to say, it didn't really go anywhere after he passed away. And then in the 1980s, theorist David Lewin kind of resurrected it and developed what we now know as the modern field of transformational theory. And the 2-second blurb about about transformational theory is that it's looking at musical actions, or another way to put it is that if we have traditional theory looking at musical objects like a C major chord or an E major chord and analyzing the objects as individuals, transformational theory is looking at how they move between each other. And usually this is done by looking at voice leading. So in this example, a traditional analysis might look like calling the C major chord the 1 chord and the E your 3 minor. The transformational way of looking at this is to say this is a leading tone transformation because the root of the C chord travels down a half step to form E minor in second inversion. So it's about how things are moving. Now, there have already been some attempts to analyze post-bop harmony using transformational theory. They're quite a lot more complex than just the simple triad example I showed you a minute ago. Up here on the right, we have an example from theorists Keith Waters and Kent Williams. And this is a tonets or tone network. It's a visual way of displaying chords on a graph. And this is a really complex tonets because it's designed to show you how ninth chords relate to each other. So in this particular example, we have A flat major 7, sharp 5, sharp 9. And it draws from the hexatonic scale, so you can see it's on the lower half of the tonets, which is labeled for hexatonic chords. The upper half would give you octatonic chords. And then the shaded regions are meant to represent a plane behind the first plane. So it's really a three-dimensional tonets. And those shaded regions would be for tracking whole tone related harmonies. And then of course left to right, you can see the pitches go around the circle of fifths. So from left to right is being used to, or would be used to map traditional diatonic harmonies like minor seventh chords. So it's useful and flexible, but I would argue really complex. And that brings us to our example on the left, which is from theorist Garrett Michelson. This is his analysis of the chord scales in Wayne Shorter's composition ESP. Now, the method he's using is called geometric scale spaces. And the intuitive way it works is to kind of draw scales that are closely related, close to each other in the graph. So for example, you can see B flat acoustic kind of up in the lower right-hand side. Here, I'll just select it with my pointer.
You're talking about our right. To our right.
Yes, to your right. That's correct. So B flat acoustic right here. Another way of saying E altered dominant is most closely related to F diatonic, right? There's only one difference in note between the two of them. So they exist right next to each other on the graph. Alternatively, you can see C diatonic and C flat diatonic are on either extreme end of this graph, and they only share one pitch. So they're going to be the least related. So it's very intuitive for seeing just how broad the harmony of a piece spans, right? However, I would argue it's less intuitive for seeing how harmony moves throughout the form of a piece. Now, he has attempted to give us some of that information. You can see the arrows and numbers next to each of these scales. And those are referring to measure numbers and how the measures flow to each other. So measure 1 features B flat acoustic, measure 2 F diatonic, etc. And it does give us that information, but if I'm trying to craft an approach to improvising over this tune from this chart, I would argue it's going to be a lot more work for me to grab my information in this format than if I were to write the chord scales out. And that kind of brings me to the reason I decided to pursue this study is because I feel like there's a real opportunity to provide an approach to improvisation that combines some elements of transformational theory with traditional chord scale theory, or how we teach chord scale theory. And so you can see here I have the chord scales of two chords spelled out, F Lydian and A Dorian. And there's only one half step of difference between them, which makes it easier to track in this example. But what I advocate for is the use of a graph, which you can see here. And the way this graph works is you can see across the top we have the chords themselves, my F major 7, A minor 6. Between them, I'm tracking the root movement, so up 4 half steps. And then in each column below the chord symbols, I have the chord scale itself in pitch class space. Pitch class space is another one of those things that's borrowed from the world of 12-tone theory. And essentially what it does is it allows me to compare notes without worrying about what octave they occur in. So you can see I'm always comparing C to C, D to D, E to E. And when we get F to F, I'm comparing F to F sharp because there is no F in the next scale. So you can see how it makes it really obvious for me to see just how one chord scale moves to another. And then in the middle, I'm tracking that movement. So the 1 represents up a half step, and the 0s represent common tones. And a note about the common tones, one of the reasons I feel like it's really important to keep track of the common tones between these chord scales is because that does have an effect on how we perceive the chords. In fact, there's a psychoacoustician named Richard Parncutt who did a series of tests or studies back in the 80s in which he discovered that people naturally hear two chords as closely related if they have more common tones. So that'll come a bit more into play once we start looking at the analysis. So just like earlier, I'm going to do this analysis based on excerpts of different tunes rather than an entire composition, and the excerpts will look at those harmonic characteristics I talked about a minute ago. So starting once again with axis progressions, we have another excerpt from Mr. Woody Shaw. This is a different composition from the same period called Beyond All Limits, and once again he is using an axis progression to end the bridge of his song, which I think is already kind of an interesting parallel. Instead of ascending in minor thirds, this time he's descending. And if we look at the analysis, you can see the steady minus three in between each chord, and then also 3 voice leading paths of motion between each chord. And this tells us a couple of really important things about how chords relate to each other. So the first is that the number of voice leading paths, when we have the same harmony over and over, the number of voice leading paths will correlate to how far you have to move around the circle of fifths. So if we think of the parent scale of A minor 7 being C major, parent scale of F sharp minor 7 being A major, well, that's 3 spaces forward in the circle of fifths, or clockwise in the circle of fifths, equals 3 rising voice leading paths. And then the other thing that I think is really interesting about this chart is that the voice leading paths in this particular configuration move in contrary motion with the root. And I would argue that that influences the perception of this particular chord progression, makes it sound like it's opening up a little bit, rather than a chord progression where the voice leading paths and root would move in the same motion. We'll look at that, an example of that in a second. But for now, here is that particular part of Beyond All Limits. Right, so really quick, short clip. Next, we'll look at constant structure, and once again, here's another example from Joe Henderson. And I was talking a minute ago about the difference between parallel and contrary motion in the root and voice leading paths. So here we have an example of parallel motion between the root and the voice leading paths, which I would argue makes it sound like it has an upward trajectory in the chord progression. And I particularly find this phrase particularly interesting because instead of just continuing to ascend up in whole steps, he kind of balances the tonality of the phrase with that middle transition where only one voice leading path moves, right? We're moving up a fourth, which is a very tonal sound, and then going back into this rising whole step motion. And to me, it's a very effective way to be mindful and careful about just how much of that upward pull your piece has. Next, we have a different section from Herbie Hancock's Dolphin Dance to demonstrate pedal point movement. And what I want to draw to your attention to here is just how much common tones there are in this phrase. In fact, if we look through, most of the time there's only one voice of movement. The only time you see more is when it transitions to E flat major 7 flat 5 over G. Now, to me, this really speaks to the way that having a shared root changes the perception of voice motion. Normally, we would expect to hear this as a very, very tonal phrase because there's so many common tones. However, I feel like the shared root kind of makes those little motions jump out more when we listen to it. And it makes it sound less tonal because the root's not moving throughout the whole phrase. And the other thing that I think is kind of fascinating from this analysis, I pointed out a minute ago, the E flat major 7 flat 5 kind of has the most voice motion, but it's really, to me, sounds like it's acting as a bridge to set up the next pedal point section, which is based on F. You can see there's no voice movement between that E flat major 7 flat 5 and F13 sus. So once again, it seems to me like, at least on an intuitive level, a very careful balance of just how far outside of harmony we're stepping during the phrase. And then I'll also do a little bit of analysis on ESP for alternative cadences. And in this phrase, you can see Wayne Shorter kind of juxtaposing two chords off of E7 altered. And in both cases, he's doing subtle things to avoid making these resolution points sound like a key center. So of course, in the first half of the phrase, he's resolving up a half step to a major 7th chord, which is not a traditional trajectory for resolving a dominant chord. Yet it still contains really smooth voice leading. And then similarly, he does resolve the E7 altered down a half step to E flat major, which is what we might expect from a tritone substitution. However, it's the Lydian version of E flat major. So once again, it's just a subtle shift that unsettles it just enough that we're not going to hear that E flat major as a key center. Now, why do this at all? I would argue that the reason to include these sorts of dominant chords is that historically the use of dominant chords in music has been to pull the music forward using tension and release. So, in this context, it's a way of using tension and release without resolving to any one particular home key. And then lastly, we'll look at these examples from the various symmetrical scales. Now, these are all going to come from Wayne Shorter, mostly because he uses these kinds of harmonies more than anyone else. But we'll begin with probably the most prominent example of whole tone scale in jazz literature, which is his tune Juju. And here you can see the first 11 measures. The whole tone scale, of course, is a very simple scale, made up of only whole steps. And that means that there's no shared pitches between the two whole tone scales that can occur. You can see that in the first two bars. We've got two chords with absolutely zero tones related. Now, I've continued the analysis past that point because I think it really reveals some fascinating things about the structure of this song. You'll notice once he leaves the whole tone world, I have an analysis that's called S1 negative 1. Now, this is a tool we can use to get between scales that have different numbers of notes. And will always be necessary when we're going to and from symmetrical scales. But essentially, the S is what's called a split. And what this analysis is saying is that the A flat will split into A and G with a voice going up and a voice going down by a semitone. As you see the analysis go along, you'll notice that there's more and more common tones. So that first jump back into more traditional chord structure or scale structure has only two common tones, and then the next jump has three. And so I think it's a really interesting way to structure the piece harmonically, where you've got the most dissonant chords up front, but you're kind of easing back into more consonant harmony. Next, we have an example of the diminished scale being used in Wayne Shorter's composition, Infant Eyes. And this is actually the middle of a phrase, or the middle between two phrases, I should say. So the end of the first subphrase with A13 flat 9 setting up the beginning of the second half of the A section. And once again, what you can see here is sort of the use of diminished as another form of alternative cadence. So the root motion is very irregular, up a tritone, down a minor third. Doesn't really make sense from a tonal point of view. But if we follow the voice leading paths, what you can see is there's a lot of contrary motion happening going into the diminished scale and out. That's going to lead to that kind of forward motion that we get from dominant chords. And then at the same time, a good number of shared tones across each harmony. Make sure that it's not sticking out too much. And then lastly, we have an example from the hexatonic scale. And this, what I think is interesting about this example is that the chords surrounding that middle A flat major 7, sharp 5, sharp 9 are pretty traditional. I mean, F sharp 7 has B as a parent scale, A major 7, sharp 11 has E as a parent scale. They're really closely related, right? But this middle chord is like coming out of the hexatonic world, which is sonically very strange. What I find fascinating, though, is that it's the same number of voice motions and common tones on either side of this hexatonic scale. And so what I'd argue its use is in this phrase is to add more of a coloristic transition between these more traditional harmonies on either side. Yep?
So there's been a lot of discussion about this hexatonic scale. Do you guys know what hexatonic scale is?
Oh, yeah. Thank you for
Just one picture.
yeah. So the hexatonic scale is another form of symmetrical scale, like the diminished scale. Diminished would be minor third, half step, minor third, half. Or sorry, whole step, half step, whole step, half step. And our hexatonic scale, as is outlined here, that one would be minor third, half step, minor third, half step.
Also known as AKA minor third half step. We talked about it a little bit in one of the symmetric scales.
Yeah, another title for the same scale. Thank you, Trent. In any case, let's hear an example of it being used in a piece. Miles Davis on trumpet. Hexatonic scale. And back to A major 7, sharp 11. So, I've already mentioned it a couple times, but the big takeaway I have from a lot of these examples is that really the approach that, at least on an intuitive level, I would argue a lot of these post-bop musicians are using to harmony is to carefully balance that voice leading motion with common tones throughout, and use that as more of a structural element throughout the piece than a key center. So in the last part of my talk, we'll just look a little bit at what we can do with this information, how it can inform improvisation in a post-bop context. And to do that, I'll be using the Wayne Shorter composition, Speak No Evil. This is not only one of the most popular post-bop compositions. Yeah, Jay, if you want to come up here, we'll do a little playing. But it has this turnaround in the second half, measures 9 through 11, that features a lot of the harmonic features that I've already been talking about. So, for example, you can see E minor to C minor. That's already referring to an axis style progression. C minor to D minor, it's a whole step, that's constant structure. And then we have A7 alt going to B flat minor 7, and that's an alternative cadence. So, to begin with, one of the first things I advocate for is reorienting your chord scales so that they highlight the differences or the half-step paths throughout a chord progression. So my analysis is on the left, and I've highlighted the various paths in blue so that it's a little bit easier to see where I'm going. And once again, what I advocate for is instead of playing through these chord scales like which it gives you a sense of the root motion, but not a sense of where the half-step connections are between the chords. So instead of doing that, what I advocate doing is starting on one of these voice leading paths and then just continuing with the starting note always on one of these voice leading paths. So in this example, I start on B and follow B flat, A flat, and then back up to A. Right? And you can do a couple of other things, you know, just to kind of get your ear inside the voice motion of the harmony. One of the things this chord progression allows you to do, not all of them will let you do it, is combine two voice leading paths. So the second line, I have the voice leading paths that start on B and E combined, so I can ascend to one, descend to the other, ascend to one, descend to the other. And these are really not less improvisational strategies and more just to get the chord progression in your ear. When it comes to improvisational strategies, something we can do is we can start to look at all the common tones. So now we have the same analysis, but with the pitch classes reduced so that we can only see those pitches that are shared between two or more chords. And the most striking thing to notice first is that we have one pitch we can use throughout this entire complex chord progression, right? I could just do some rhythmic variations on G, which I'll demonstrate now with the help of my friendly quartet here. 1, 2, 1, 2, 3. Good. And then similarly, I could just start to introduce complexity slowly to this. So here's two pitches. 1, 2, 3, 4. Cool. And then going a step further, what I have in the third line is an 027 trichord. So I'm incorporating a little bit of that 12-tone approach. And the same 027 trichord, unfortunately, can't be used across the whole phrase. But it does give me an opportunity to kind of suggest or infer a different motion in the chords by transposing that same trichord down a third. So here's a little example of that. 1, 2, 3, 4. Yeah. So you highlighting changes between chords or common tones, that's just kind of like the tip of the iceberg as far as I'm concerned, the basic stuff. Really where I think this analysis gets powerful is when it's showing you contrapuntal motion between the voice leading paths. So these next exercises are going to demonstrate melodies that kind of use this contrapuntal motion to influence the contour of the melody. So the first one we'll look at is similar motion, and this is any time that there is a voice leading path or two paths that move in the same direction at different speeds. So I've got an ascending voice leading path highlighted here. You'll notice it wraps around to C once it gets to B. So it's still ascending even though it's in the bottom corner of the graph. And then what I have is an example of just an arpeggiation built off of each note in the voice leading path. So you'll hear kind of the arpeggios ascend more rapidly while the voice leading path continues to ascend in half steps. 1, 2, 1, 2, 3. And then similarly, an even more extreme example of this, in the lower half, I have ascending fourths based off of each note in the voice leading path. 1, 2, 1, 2, 3, 4. Cool. Yeah. Moving along, the next thing we can look at is parallel motion. And so now I have all the descending voice leading paths highlighted only. And this is going to inform me just what kind of options I have. So the simplest, of course, would be to play off of two pitches. So in this first example, I'll start with B and C sharp. And I'm just going to play off of them as they descend in half steps. 1, 2, 1, 2, 3, 4. Cool. Now, of course, because they're right next to each other, I just kind of play between them rhythmically. But if I invert these two, now I've got a bunch of space in between them to play off of a little bit differently. So that will be demonstrated in this next example. 1, 2, 1, 2, 3. Cool. And then, of course, I can keep on adding these voice leading paths to create really complex melodies that are always descending in a half step. So this next one is trichord 025 starting on B. 1, 2, 1, 2, 3. And similarly, I can even add the fourth voice in to add tetrachord 0247, which I'm throwing out all these numbers, but you might recognize this particular shape as being very similar to a pentatonic scale, right? It's a shape that occurs within the pentatonic scale. 1, 2, 1, 2, 3. Moving on to our next example, we have oblique motion. And this is where we have any held pitch or steady voice leading path, common tone, against a moving voice leading path. So this first melody, you're going to hear my melodic shape expand throughout the phrase. 1, 2, 1, 2, 3, 4. Once again, if we invert this, we get the opposite effect, a melody that starts far apart and comes in close. 1, 2, 1, 2, 3. And then the last motion to talk about is contrary motion. As you can see, I have an ascending and descending voice leading path highlighted. And once again, the inversion that you choose will dictate whether it's a melody that gets smaller or wider. So the first example is a melody that gets wider. 1, 2, 1, 2, 3. And then, of course, the inversion, it kind of converges in on itself. 1, 2, 1, 2, 3. So, to kind of conclude the whole talk for everyone, a few observations that I would like you all to leave this room with today. The first is that post-bop jazz defies the conventions that traditional chord scale theory is based on. So I would argue it doesn't make sense to teach traditional chord scale theory or to teach chord scale theory the way it's traditionally taught in a post-bop jazz context. Secondly, post-bop harmony is structured around this careful balance of voice-leading paths, contrary motion, and common tones between the harmonies. Once again, obviously, I don't have any proof if these concepts were being thought of when these composers wrote it. Probably it was more of an intuitive decision that they were making with their ears. And then lastly, if we teach chord scale theory in a way that highlights these unique contrapuntal relationships between the chords, we can kind of not only help students and improvisers hear those unique relationships, but we can influence a more creative, I would argue, approach to improvising in this music. So because improvisation is really about the study and then the application part of it is about the intuition, the last thing I'd like to do today is we're just going to play, I think, a chorus of Speak No Evil. I'll improvise. I'm not going to consciously try to use any of these things, but I have been practicing them. And so we'll see if any of these concepts happen to come out. And let's just do a single chorus right from the top. 1, 2, 1, 2, 3. So, boy, that takes us right up to 12:04. So if anyone has a question, you're welcome to ask them now, or you can speak to me while we're all packing up and cleaning up.
Is that pretty clear to you guys? I think it was very well presented. Yeah.
I will ask you guys to give a round of applause to my rhythm
Yeah.
section. Jay, Cho, Trent, and class. Thank you guys for being here and for providing great harmonic and rhythmic context for what I was playing today.
Yeah, while you guys are packing up, I think it's what's cool about this is just like you were saying there at the end, like being appreciative of this approach. I think just being aware of it
Yeah.
helps.
Yeah.
I mean, just like saying, oh, you know what? Because we talk about common tones and we talk about other stuff, but really see it laid out in a graphic form is it's interesting. You know, it's and like you said, these composers may not have gone about formulating their music that way, but even though it may have been intuitive for them, for those of us who it might not be so intuitive, it might open up a gateway to that intuitiveness by just understanding it.
Yeah, and like to give you an example, I really did try and just let go of all that I'd been talking about for the last hour,
Right.
and just try and use my intuition playing through it this time.
But you can hear the influence.
Exactly, and that's
Because I haven't heard you play for a while too. So
well, yeah, that's also true.
It's cool.
All right, thanks for being
Thank
here,
you.
everyone. Appreciate it.
Thank you, Bear.